Our next chapter in physics is about the nature of forces. So what is a force? A force is pretty simply defined as either a push or a pull. So if object A pushes or pulls on object B, then we can say that object A exerts a force on object B. If I am object A, I push on object B, which is a door. The door opens because of that force. I accelerate it. I change its velocity. So yep, force is just a simple push or a pull. Like velocity and acceleration, force is determined by strength and direction. So we do need a magnitude and a direction. If you ever seen Despicable Me, we have a villain called Vector. He does crimes in both magnitude and direction because he's a vector. Force is a vector. So we do need direction with it, and we do need a strength of that force. Forces are going to be measured in newtons. Newtons will be abbreviated by a capital N. Just to give you an idea, you exert a force of about 1 Newton when you decide to lift a small lemon. So just picking up a small lemon, 1 Newton of force required. So how do you represent forces? Well, forces are vectors, so they are going to be represented by an arrow. Arrow is going to show strength by the length of that arrow, and is going to show direction by the arrow's actual head. So here we have an example of a force of 15 newtons to the left, that direction. Combining forces. Forces can be combined. Often more than one force acts on an object at a time. For example, if you decide to lift up a lemon, you are acting on the lemon and exerting a force, while gravity is also exerting a force downwards. Well, you probably also have friction exerting a force trying to make that lemon not fall out of your hand. The combination of these forces is going to be called your net force. So your overall forces combined is going to be your net force, and forces combined pretty simply mathematically. For example, if I have two forces of 5 newtons going in the same direction, they can combine to form a force of 10 newtons in the same direction. If you could think about that, if I am pushing on a door for 5 newtons worth of force, and my buddy is pushing on a door for 5 newtons of force, that would be the same as one of us pushing on the door for 10 newtons of force. Forces in opposing directions also add together. However, they tend to cancel out. So if I am pushing for 5 newtons of force on that door, my buddy is pushing for 5 newtons on the other side of that door is probably not going to move, and therefore I have a net force of 0 newtons. If I have a force of 5 newtons on the door and my buddy is doing 10 newtons on the door, then that would be a force of 15 newtons. So they simply just add together. They can cancel out, playing with pretty much the same rules that integers use in math. So they're pretty straightforward there. Net forces will always act in the direction of the greater force. So if I'm pushing on the door for 5 newtons in one direction, my buddy is pushing on it for 10 in the opposing direction, then my buddy is going to push the door for a total excuse me, my buddy is going to be pushing on the door for a total of 5 newtons in the opposing direction as me. If opposing forces are equal, they do cancel out and motion will not change. That's important. Motion will not change. If the object is currently moving at a constant velocity, then 0 net force, or all those forces will cancel out. It is still going to continue to move at a constant velocity. The easier way of looking at that is when something's at rest and all the forces cancel each other out, then it's going to stay where it is. It's not going to change its velocity, or therefore it's not going to accelerate. Unbalanced forces, however, cause an acceleration. So whenever the net force acting on an object is unbalanced, so all the combination of the forces are unbalanced, and one direction is going to beat out all the other ones, it's going to be unbalanced, and then it will accelerate. So it will do 3 things. 1, it will start moving. It will either stop moving, so it will accelerate, speed it up, slow it down, or it will accelerate by changing the object's direction that it moves. All will happen with an unbalanced force. Again, if forces are balanced, then you will get no change in motion. So here's some examples of balanced forces. Here we have an object. We can assume it's just a box. It could represent whatever you want it to, but this here is just a box. And let's say we have two forces of 50 newtons acting in opposing directions and two forces of 30 newtons acting in opposing directions. Well, these two forces are going to cancel each other out, and these two forces are going to cancel each other out, making a net force of 0, and therefore a balanced force, and this object will not change its motion. Now, I am not sure at this point whether this is at rest, and therefore it'll stay at rest, or whether this object is moving at a constant velocity, and therefore stay moving at a constant velocity. Over here we have the same scenario. Even though we are pulling on it in a slightly stronger way in left and right directions, the front and back directions are still going to be the 50 newtons. It's still going to cancel each other out, and you will still get a net force of 0, and therefore you will still not get a change in motion. You can think about this like arm wrestling is a good example. So if you're sitting there arm wrestling your buddy, you're pushing 5 newtons on his hand while he's pushing 5 newtons on your hand. They're going to cancel out, and neither one of you are going to win. You're just going to be in a stalemate until one person decides to either use less of a force or the other person decides to use more of a force, making an unbalanced force, and therefore your arm will actually move. Same thing goes with tug of war. If you're on field day playing tug of war, and you have 5 people pushing at 5 newtons each on one team and 5 people pulling at 5 newtons each on another team, you're going to get a balanced force, and that rope is not going to go anywhere. It's only until one of those forces needs to change and it becomes unbalanced before you actually get motion happening.